In this chapter of our program, we are going to talk mostly about arc flash and the key test used to measure a garment's protection level against this hazard. So first, we should start with the definition of what an arc flash actually is. In short, an arc flash is the passage of substantial electrical current through ionized air. The result is a release of energy with intense heat, considerable pressure wave, flying shrapnel, and a loud sound blast. A simulation of an arc flash looks like this. As you can see, a worker exposed to an arc flash accident is likely to have conventional workwear catch on fire and has the potential of sustaining a very significant burn injury. The onset of second-degree burns will occur at approximately 1.2 calories per square centimeter. This is equivalent to holding your finger over the tip of a flame of a cigarette lighter for 1 to 2 seconds. An arc flash can ignite non-FR clothing, and the burning can easily exceed this 1.2 calories and last for more than a second. Key industries with workers exposed to arc flash hazards include the utility industry and any manufacturing facility with personnel working on or near energized electrical equipment. This includes maintenance crews, staff electricians, electrical contractors, and workers on assembly lines producing cars, mechanics who work on planes, even employees working for local municipalities. The primary test designed to measure a fabric's protective level against this hazard is ASTM F1959. The title of this test is the standard test method for determining the arc rating of materials for clothing. A key metric when evaluating an FR garment's protection level for arc flash is the FR garment's arc rating. This arc rating is expressed in one of two ways: as an ATPV, or arc thermal performance value, or as an EBT, or energy break-open threshold. Both are arc ratings. Both are intended to measure the onset of a second-degree burn. The more common arc rating value you will hear is the ATPV. Let's talk about how this test works. 3 flat fabric samples are placed over 3 flat panels with heat sensors positioned 12 inches away from the center of these arc electrodes here. The samples are then exposed to varying intensity arcs. The heat rise underneath the fabric is recorded by the sensors during each exposure. The resulting data is analyzed to determine the 50% probability of a second-degree burn, or ATPV. Now let's take a look at this test being conducted. This particular test shows a sample of FR fabric being tested. The arc flash is created, and you can see the intensity and the discoloration of the fabric due to the extreme heat. After performing and analyzing the data from many tests, an arc rating for this fabric is established. It is important that the arc rating of your garment is above that of the potential arc flash exposure for any given work function. This is also how the industry standards have been written. So, if your potential exposure is 7.5 calories per square centimeter, then your FR clothing needs an ATPV or EBT value equal to or higher than that. Let's look at how arc rating levels are incorporated into key industry standards. We'll start with another NFPA standard titled NFPA 70E. This is the standard for electrical safety in the workplace. It applies to most industries, with a few exceptions, most notably electric utilities, which have their own standard called the National Electrical Safety Code. A lot of you watching this are probably doing so because of NFPA 70E. This standard addresses safety requirements for employees conducting activities like the installation, operation, and maintenance of electric conductors and equipment, as well as signaling and communications equipment. NFPA 70E cites that each year, more than 2,000 people are admitted to burn centers with severe arc flash burns. The truth is, the vast majority of companies in the U.S. have some employees that work on or near energized parts and are affected by this standard. NFPA 70E provides 2 methods for determining the arc rating requirement for work practices. Method 1 is to perform an arc flash hazard risk assessment at your location. This analysis would establish the potential arc energy exposure in calories per square centimeter for the given electrical system equipment and task that is analyzed. One notable point about this method is that it gives a specific number for a given task based on your company's equipment and practices. That task will be assigned a number like 8.4 or 10.5 calories per square centimeter. Method 2 is to use the task tables within the NFPA 70E standard itself. These tables list common electrical tasks and equipment at various voltages. It groups them into one of 5 hazard risk categories, also called HRC categories. These categories range from HRC 0 through HRC 4. Each category outlines the minimum arc rating of the FR clothing that needs to be worn. HRC 0 does not require you to wear FR clothing, but the clothing must be non-melting. HRC 1 requires FR clothing with a minimum arc rating of 4 calories per square centimeter. HRC 2 requires FR clothing with a minimum arc rating of 8 calories per square centimeter. HRC 3 requires either a single-layer garment system or multi-layer system with a minimum arc rating of 25 calories per square centimeter. And HRC 4 requires either a single-layer garment system or multi-layer system with a minimum arc rating of 40 calories per square centimeter. To make implementing this standard easier for safety managers, the standard includes an Annex H, which is a simplified 2-category approach. It suggests a shirt and pant, or a coverall with a minimum arc rating of 8.0 for everyday wear. This satisfies the clothing requirement for tasks in HRC 0 through 2. But you would still need to add other PPE requirements like face shields as outlined in the standard. In addition to this daily uniform, they suggest another clothing system, like a commercially available 40-calorie flash suit, which can be put on when executing HRC 3 and 4 tasks as outlined in the tables. Here's an example of an arc flash suit. To recap, you can comply with the clothing requirement of NFPA 70E by doing a site hazard risk assessment and then match specific tasks to FR clothing that has the appropriate arc rating. Or you can refer to the task tables and match FR clothing to an HRC level which goes from 0 through 4. Finally, you can look at the Annex H option, which is a 2-category approach for daily wear plus an optional high-calorie clothing system. The Department of Energy has required that federal and contractor employees comply with NFPA 70E. Additionally, OSHA considers this standard a recognized industry practice. Utilities have their own standard to protect their workers from arc flash exposure. It is the National Electrical Safety Code, or NESC. NESC covers utility facilities and equipment up to the service point of its customers. After that point, the requirements of NFPA 70E take over. In NESC, the utility is required to perform a hazard risk assessment to determine the exposure potential to an arc flash for various work practices. If the hazard is above 2 calories per centimeter, then arc-resistant clothing must be worn. Just like NFPA 70E, there is an option for either a detailed hazard analysis or simplified tables which can be used to determine the FR clothing and appropriate arc rating. The NESC tables are based on the voltage, fault current, and clearing times for various tasks. There are 2 tables. Table 410-1 for voltages 1 through 46 kilovolts. This outlines the FR clothing requirements with arc ratings of either 4, 8, or 12 calories per square centimeter. Table 412-2 for voltages 46.1 to 800 kilovolts. Again, based on fault current and clearing times, it outlines FR clothing requirements for 4, 8, or 12 calories per square centimeter. There are 2 exceptions to this table. First, if the exposure is below 1,000 volts, no assessment is required. You just need to put workers into clothing with a minimum arc rating of 4 calories per square centimeter. Second, if the clothing required to meet a particular level has the potential to create a greater hazard for the worker than the arc flash hazard itself, then clothing of a lower arc rating may be worn. Individual states have the option of adopting the National Electrical Safety Code, or they may create their own code. Many states adopt the NESC automatically. But those of you responsible for safety at utilities should check with your state to see what particular safety code they are using. OSHA has developed a federal regulation covering rules for utilities during the operation and maintenance of electric power generation, transmission, and distribution lines and equipment. It states that when working on or near exposed energized parts, employees exposed to electric arcs shall not wear clothing that could increase the extent of injury. It specifically prohibits non-FR fabrics like acetate, polyester, and rayon. OSHA has been working on updating 1910-269, and word has it that a revised standard is coming out soon. It is expected to include clothing requirements that would require companies to do a hazard risk assessment and to protect workers from electric arc flash hazards. As you can see, strong standards have been developed to help safety professionals determine ways to protect employees from the very real and very serious risk of arc flash. OSHA is even looking at strengthening their regulations. Well, that's it for this chapter of our program. We'll see you back in our final segment as we take a closer look at flash fire hazards.